Hi, this is Mrs. Tellas. I'll be covering chapter 6.1, the last section, dividing powers. Okay, so if we use our first page here, let's see, 9 would be the common factor here. So that would become a 2, and that would become a 3. You could also use your calculator, 18, ABC 27. Both of these are unhappy, so we would switch their positions. This one would come up, and that one would go down. The 2 and 3 would stay put. So y to the second, x to the first. And when I don't really need the 1. This is the answer to the first one. Here, 4 goes into both, so that becomes a 1 and a 3. And again, you could stick that in your calculator, 12 divide 4 or negative 12 divide 4. The only unhappy one here is the c, so he's going to go up to the top. Everything else stays up there. So negative 3, a to the third, b to the fourth, c to the seventh, and everything else, it's just a 1 on the bottom, and I don't need to write that 1. Okay, here 50 goes into both of these. The 2 negatives make a positive, so we'll change those right away. 50 goes in here twice and in here 5 times. And the z is unhappy, so he is moving to the bottom. The y stays down there. So that's 2 over 5, y to the 7, z to the 4. Okay, those are so kind of review problems. They look like division problems because they are fractions, but I didn't do a whole lot of dividing. Here I did the ABC. I could divide, but I don't want decimals here. So I want fraction answers. All right, so this is the new information when we divide powers that have the same base. Subtract the exponents, and the base stays the same. And hopefully you see that as a common thread. The base always stays the same. So these are common bases. You notice that the bigger one's in the numerator, so I'm going to go up to the top. The top will win the answer. So 7 minus 3 is a to the 4. Okay, here there's more on the bottom, so I'm going to go to the bottom. B to the 8 minus 5 is 3. So when I get a little bit more complicated here, I've got 2 of them. I have these 2 x's to deal with and these 2. And notice I can only divide things that have a like base. So I'm going to go up to the top to do this. So this will be x to the 6 minus 1 because that has an exponent of 1. And this is y to the 3 minus 2. There's more up here. So my answer is x to the 5th, y to the 1st. And I don't really need a first power. Number 3, same thing. I'm going to do the y's and the z's. So I'm going up to the top because there's more up there. Y to the 8 minus 6 and z to the 10 minus 4. So that's y to the 2, z to the 6. And everybody's happy, not moving anybody anywhere. Okay, an expression has to have all positive exponents. So it's not considered simplified if it contains negative exponents. All of the exponents must be made happy for you to be done. Okay, so if I look right here, 2 and 4, you can type that in your calculator. 2ABC4. 2 goes in once, and 2 goes in here twice. These 2 are unhappy, so we're going to move them. So on the top, we're going to put y to the 4 up there. It has a 1. On the bottom, it has a 2 already, and the x is coming down, and the z stays. And this 1 here is optional. Whether or not you have it, that's okay either way. 75 and 15 share a common factor of 15. I believe that's 5 times. Okay, so this is an actual division problem. This above here was just making things happy. So I'm going to combine the p's, and I'm going to combine the q's, and I'm going to make the r happy. So the 5 and the 1 are staying the same. I'm going down to the bottom for the p's. So p to the 5 minus 3, which will be p to the 2. And which is bigger? The negative 4 is bigger. So again, I'm going down to the bottom. So q to the negative 4 minus negative 5. That's q to the positive 1. And then the r was unhappy, so he goes to the top. So r to the 8. And this one is optional, and so is this front one. So this is my answer. Here, this one's much simpler than that one. The number 5 was a little bit more difficult. So -4 is fine where he is. There are more x's to the bottom. So I'm doing x to the 5 minus 3, which is x to the 2. This is my answer. The 2 and the 3 will stay the same on number 7. I've got a little bit of division going on here and here. And then I've got an unhappy C. And I will deal with that in a second. So there's more down here because this is a positive 1. So this is a to the 1 minus -2, which is a to the 3. And there's more up top on the b's. So I went down for the a's and up for the b's. So b to the first minus -2. That's also positive 3. So right here is going to go a positive 3. And then C is going down to the bottom because he's unhappy. And that 1 is something that is optional. You don't need that 1, but you can have it if you'd like it. And this is the answer. A lot going on in these problems. All right, to find the power of a quotient, find the power of the numerator and also the denominator. So the numerator is the top of the fraction and the denominator is the bottom of the fraction. So both of these have a power of 1 already. And we're going to use our power to a power rules. So I copy the base, and 4 times 1 is 4, and 4 times 1 is 4. So my answer then is a to the 4th over b to the 4th. I'm always going to copy that base before I do that multiplication. It applies to numbers as well. These both have exponents of 1. So I copy the 5, and 2 times 1 is 2. I copy the 2, and 2 times 1 is 2. Since they're numbers I can evaluate, this is 25 over 4, and an improper fraction is perfectly fine. Okay, same thing here. I've got a negative exponent, but it's the same algorithm. It's the same method. I put a 1 here and a 1 here. They're already there, they're just not written. So I copy the base. That would be to the -2 because 1 times -2 is -2. I copy the base. 1 times -2 is -2. They're both unhappy, so I switch them. Now they're happy, and I can evaluate. So that ends up being 64 over 49. Okay, here, same thing. I've got to raise all of them to the 3rd power. That 3 has a power of 1, and so does the 4. So I copy the 3. What's 1 times 3? 3. I copy the base p. What's 2 times 3? 6. And in the denominator, I copy the 4. 1 times 3, 3. Everything's happy. I just need to evaluate. 3 to the 3rd is 27. P to the 6 is fine where he is, and that bottom is 64. That's my answer. Number 10 is pretty much the same thing as number 9. I'm putting an exponent of 1 there where there isn't an exponent. Copying the base, multiplying 2 times 1. Copying the base, multiplying 3 times 2. Copying the base, multiplying 2 times 1. Copying the base and multiplying 4 times 2. So 2 to the 2nd is 4. 3 to the 2nd is 9, and the variables just get copied because they're fine where they are. That's the answer. Okay, number 11's got a negative exponent, but it doesn't change what I do. I do the same thing. So this is a 1 here. So I copy my base. 1 times -2 is -2. Copy my base. 6 times -2 is -12. Copy my base. 4 times -2 is -8. All of them are unhappy. Every single one. So every single one needs to move to the opposite part of the fraction. So that one's going up. 2 to the 2nd is coming down, and so is x to the 12th. And then I just need to evaluate 2 to the 2nd, which is 4. And that's my final answer. Number 12 is very similar. Okay, I've got an exponent of 1 here, an exponent of 1 here, 1 here, and 1 here. Since there's no exponent showing, it's automatically 1. Each time I'm going to copy the base. So I copy the base and multiply. 1 times -3 is -3. Copy the base. -2 times -3 is 6. Copy the base b. 1 times -3 is -3. Copy the base. -3 times -1 is +3. Over. Same thing on the bottom. Copy the base. 1 times -3 is -3. Copy the base A. 1 times negative 3 is negative 3. Copy the base B. Negative 2 times negative 3 is positive 6. So I have some unhappy ones. I think I'm going to go ahead and move those. There's quite a few of them. And then the rest is going to stay the same, and then we'll see what we've got left here. So we're moving 3 to the third to the top. A to the sixth stayed. A to the third went up. C to the third stayed. On the bottom, 2 to the third moved down to the bottom. B to the sixth stayed. And B to the third moved down to the bottom. So there's supposed to be 1, 2, 3, 4, 5, 6, 7 terms or letters, items. 1, 2, 3, 4, 5, 6, 7. Yep, we got them all. So 3 to the third is 27. 2 to the third is 8. So my numbers are fine. On the top, I can combine these A's. This is a multiply problem. And on the bottom, I can combine the B's. Same basis means that I'm multiplying and I'm adding the exponent. So this is A to the 9th power, 6 plus 3. C to the third stayed, and then B to the 9th power, 6 plus 3. That's my answer. Okay, and I think looks like I'm all done. Any questions, please let me know. Email me, ask me in class. Any of those things totally work. And thanks for listening. Bye-bye.